Okay, and this thing is recording. Okay, how do we do the calculations on the friction lab? Now, first of all, you had two blocks. Block 1 we decided was sandpaper and rubber. The block 2 was the hard plastic and soft plastic. The weights, I've got some sample data here, so I'm just going to use some numbers from this sample set that I've got up here. The weight of one block was one thing, the weight of the other block was something else. Then you had to pick some combinations of things. We did not do a case 4. Case period 4 in particular got away with not having to do 2 cases, so they didn't have to do a case 3 or 4. But they're the guinea pigs and we were running slow. All right, so I cut them a break for once. Now let's say case 1 is soft plastic. Oh, and the gladiator pins have just been ordered. All right, in case you want to get one of those. All right, since I'm using a Chiefs pin here. Okay, fine. And the soft plastic one was this one. This was the soft or hard plastic up here. So my weight for case 1, the soft plastic block was 2.5 newtons. People keep confusing what they're supposed to put there. That is the weight of that particular kind of block. Then you had some force of static friction. What did it take to get it started? This particular person had very consistent data at 0.5 newtons every single time. Right. Then for the force of kinetic friction, it was just a little bit less than that. 0.5, a 0.3, and a 0.4. Right. Which, to be perfectly honest, I'm nudging the numbers around just for the sake of doing this because I want them to the calculations come out nice and easy. For his angles, he had 20 degrees and 18 degrees and 19 degrees. The average of my force of kinetic friction is the average of this one, and this one. Those 3 things there go into this average. So that's an average of 0.4. Now, here it said that it was newtons. Here it does not say newtons, so I'm going to say newtons inside. If it doesn't say the units up top, you got to write it inside the box. The average for the force of static friction is that one, and that one. Well, that's easy. That's 0.5. All right. Now it comes around to actually making calculations. My coefficient of kinetic friction is equal to my force of kinetic friction divided by my normal force, which was my average value divided by, on a horizontal surface, what's my normal force equal to, guys? The weight of the object, okay? So the weight of that particular block. So for my example situation here, I've got 0.4 newtons divided by the weight of this block, which was 2.5 newtons. So then you grab a calculator, and 0.4 divided by 2.5 for me ends up with a value of 0.16. Don't give it more than 2 decimal places, please. Right? The coefficient of static friction is the same way. My coefficient of static friction is my static frictional force, which is going to be my average, divided by my normal force. My normal force is, again, the same thing as the weight. So for this one, it's going to be the 0.5 newtons divided by the 2.5 newtons, which gives me 0.20. No units because they cancel out. So that's my calculated coefficient of static friction on the horizontal surface. Now, the coefficient of static friction on the incline, that came from our angle. My coefficient of static, okay, this one here was horizontal. This one here is on the incline. My coefficient of static friction was just equal to the tangent of the angle of incline. That should be the average value. Didn't make a spot for the average value. I'll hopefully remember to add that next time. 20, 18, and 19 average out to be 19. So the tangent of 19 degrees, clear that out. tangent of 19 degrees is 0.34. Okay, so I've got 0.34 here. All right, now for some of the tricky parts. The first tricky part that throws people off is the change in the coefficient of static friction. Guys, that is the comparison of these two values which are next to each other. That's it. Subtract them, give me the positive absolute value of it. So that's going to be a difference of 0.14. That's pretty sizable. The two methods didn't seem to agree very much. Right? Now, it wasn't a percentage. Did not do a percent error, because to do a percent error, we got to say that one of these is the accepted value. I didn't want to say that either one was the accepted value. I'm expecting your values to be better than this. I kind of nudged this data around, and I think I made it worse when I nudged it. Okay? I'm hoping that that number is going to be small compared to these two numbers. All right. Then with the 400 grams. Here's the part that confuses people the most, or at least quite a bit, is that we have to add in the weight of 400 grams, guys. The weight of 400 grams is equal to that mass multiplied by gravity. Well, 400 grams is the same as 0.4 kilograms. 0.4 kilograms times 10 newtons per kilogram, or if you want to put meters per second squared, that's fine. Gives me 4 newtons. That's the addition. So I'm going to take that weight and add 4 newtons to each and every single one of these. Each of these gets an additional 4 newtons. So that's going to go from 2.5 up to 6.5. Right. Then he had some values here. I'm just going to jot them in real quick. 1.5, 1.4, oops, 1.4, 1.6 over here. Actually, I'm going to change that to 1.4, 1.4, 1.6, and 1.3. Down here, just so I can get some values in here, my average of the kinetic ones, 1.4, 1.6, 1.3. This one I think I got to put in a calculator. 1.6 plus 1.4 plus 1.3 divided by 3. Yeah, not an even number, but it was closest to 1.4. 1.4 newtons. For my coefficient of static friction, these three here, that's going to be 1.5. 1.5 newtons. My coefficient of kinetic friction is the same way I did up there. I don't need to rewrite it because that was my sample calculation. So it's going to be 1.4 divided by the new weight, which is 6.5. In fact, I might just write down just to emphasize. Force of kinetic friction divided by my weight, which is going to be 1.4 newtons divided by 6.5 newtons. 1.4 divided by 6.5, leaving me with 0.22. Don't give me more than 2 decimal places. Over here, I got to finish this up, otherwise I can't do the last calculations. Over here, I'm going to have 1.5 divided by 6.5. And that gives me 0.23. If we had really good data, guys, the coefficient of static friction should be a little greater than the coefficient of kinetic friction. Most of the time, you don't see a difference until you're down here with the plus 400 grams. All right. So this one is the difference between these two. These ones, these guys right here, are the difference between the vertical pairs. All right. So the change in my coefficient of kinetic friction is going to be the difference between this one and this one. 0.22 minus 0.16 leaves me with 0.06. And then this one is going to be this one and this one. Those two paired up. So 0.23 minus 0.20, I got 0.03. We usually find that these ones are pretty dang small. These are the same method, only with slightly different values, and they should not disagree with each other by very much. All right. Doing that, you should be able to populate everything and be done with this lab activity. Good luck.